Why this is important? This is important because, for example, for websites, many often we have, almost always, we have different test environments. It will be a better option if you don't have so many tests, if not so many teams are using the framework. For example, if you're working in a single repository, we are encapsulating all configuration settings within this single class. We have the default browser, which will be Chrome. We have the browser version. How to implement? If you remember, these profiles will give us this command name. The only configuration that will be copied to the bin folder will be the one that holds the correct suffix equal to the configuration picked right here. Hi guys, greetings from Bulgaria. This will be our next module out of our Advanced Test Automation Frameworks Development course. Before we begin, if you haven't subscribed to the channel, please do so. Hit the ring bell so that you get notified when new videos are published. Also check the awesome 𝑨𝒏𝒕𝒐𝒏 blog because there are so many detailed articles about automated testing and they will definitely help you to become a much better test automation engineer. In the links below, you will find all of the relevant resources like articles and websites, and also the GitHub repo for the framework. I suggest to clone the repo and work with me and check the code while I give my explanations. And as for the rest of the modules, I'm not creating a separate repository for each of the modules, but instead I'm creating different branches for this framework because we are upgrading the solution and you will have access to all the upgrades bit by bit. So in this particular video you need to clone and check out this configuration management branch. Also in the links below you will find jump links to particular parts of the video if you want just to skip some or etc. So let's begin. I won't again repeating the whole course overview, but before we begin I suggest you to check all of the modules one by one if you haven't done so. We define the scope and the requirements for our framework. I explain a system for picking and deciding whether you need to create a framework or not. Then we built some modules about web, mobile, we upgraded them through plugin architecture, and we upgraded the solution further for allowing the framework to execute mobile and web tests in the cloud and doing a responsive and layout testing. And now it's time to further upgrade our framework and support global settings, global configurations through files or some let's say coded approach with the settings. Why this is important? This is important because, for example, for websites, many often we have, almost always, we have different test environments like staging, QA, production, local environment, or like in an enterprise project that I'm part of right now, before release, the application is deployed to multiple compatibility instances where we need to check that everything is alright. We have different URLs, different performance, different timeouts are needed, and other settings are different basically. So we need a way for us to have these different settings instead of hard coding them in the code. An easy way. We can do that through static classes, I'm going to show you that, and also through JSON files. And we are going to use a pattern called options design pattern. Actually, partially we use it, but we haven't implemented it fully. In a second, I'm going to explain what is this. This is also important for our mobile module because as you saw in the last module when we were talking about responsive testing, especially on mobile devices, no matter whether this is a native application or a website that you need to check on real mobile devices, we have a lot of configurations between operating system, mobile devices versions, versions of browsers, browser types, etc. So we have tons of configurations that especially for hybrid apps or native apps, we need to check them on so many devices. And this is how we are going again to utilize this capability of the framework to be able to configure this globally. Why we're researching two different ways of doing that? Because depending on multiple factors, one of the solutions may be better than the other. At the end of the module, we're going to compare these two approaches. For example, the implementation with static classes, it will be a better option if you don't have so many tests, if not so many teams are using the framework. For example, if you're working in a single repository. However, if we have a more complex architecture where we have so many teams distributed around the globe, if they're using our framework as a Git submodule, and we need the flexibility to add additional settings to our files or classes, then probably the solution with JSON files will be better. But again, we're going to compare them in much more details when you see the actual implementations of those two approaches. Now, let's see and talk about the options design pattern. Here is a sample diagram. The options design pattern is a creational design pattern and is used primarily to simplify the configuration of complex objects. It involves the use of a class, often referred to as an options or configuration class or settings. I will use settings in our case. And it encapsulates all of the configuration settings required to initialize or customize a particular object. This pattern allows for more flexible and readable way to manage optional parameters and default values. Again, we already use it. Just in short, I'm going to show you that. We already had a similar class called browser configuration that holds now it holds the browser version, the life cycle where we need to restart the browser every time or reuse it, the execution time whether it's grid or local, the size, etc. So this is basically an option class, but again, as I said, we are partially implementing it because here we don't have default values. Actually, the default values are initialized partially in some of the constructors and inside our attributes, like for example our lambda test attribute. Here, as you can see, we are initializing a lot of the default values for the grid settings. And some of the key characteristics of this options design pattern is that we are already doing that. We are encapsulating all configuration settings within this single class. Instead of passing 7 or 8 parameters to constructors or methods. Also, we have the default values. Again, this is partially done, but it will allow this sensible default values for each configuration setting, reducing the need for these overload constructors like we have them right now. Like right here, we will reduce the count of these constructors. Many often immutability is achieved through usage of, for example, records or immutability types. Right now we don't have a fluent interface, but we are going frequently, it's implemented with a fluent interface similar to the actions class or builder classes, and this will enable chain of method calls for setting different configuration options. We're going to do that for the static version. And separating the configuration logic from business logic, this will enhance the maintainability and readability. And if we return to the diagram, this will be what we're going to try to do, at least for the static version. We're going to create a separate settings classes that we are going to use them as static properties. This will be the web settings and the Android settings. They will hold all of the relevant settings. And also we are going to use fluent interface for exposing two more related settings, timeouts and grid settings. And we are going to use them through fluent interface through these static classes. However, in order to achieve these different settings for the different environments, we need this class here, configuration loader. It will be responsible to read from an environmental variable or .NET profile. I'm going to explain a little bit later what is this. through these profiles or environmental variables, we will switch configurations. And these methods here, they will initialize differently our static classes. Later, through this static class, we're going to use our settings. So let's get started and see how we are going to implement this static classes version of the settings. Right now, again, I will leave in order to skip some problems with the refactoring. I will leave now the browser configuration. I will leave those classes here. Instead, I'm going to create a new folder here called settings. And in this settings folder, we're going to create two namespaces. The first namespace will be file implementation, and one more for the version that we're going to use now, implement now, static implementation. We're going to do absolutely the same for the mobile. Here we will have a similar namespaces. So right now, as I told you, we will need these settings, the static version. We will start with this web settings. In this web settings class, we will put all relevant, all other configuration properties that we need. For example, we will have access to the execution type. In order to implement fully the options design pattern, right now, as you can see here, I'm initializing a default value, right? I'm setting that the execution type is lambda test. Our web settings class, you will see when we talk about the file version, will be slightly different, because when we work with text files, JSON files, all of the properties will be strings. But here we have the other possibility to work with different enumerations that we have defined, which is excellent. We have now the default life cycle. I said that the default value will be restart every time. And what else? Also, we have the default browser, which will be Chrome. We have the browser version. And what we are missing, if we look into again our plugins, for example here, and if we see the browser configuration, you'll notice that the last time when we were working and configuring our local execution attribute to support emulation, so we need to have that as well. So I'm going to copy those, and we'll have to assign them some default values. Again, we need to make them static. We need to add a using to the drawing, and I'm going to make all of them static, right? Right now we are not fully implementing the options design pattern. In order to do that, for the size, if you remember, we have a class that it's called Windows Size Resolver. This Windows Size Resolver have a method Windows Size, which accepts our enumeration, which is this desktop window size, and based on it, it will return, like here, it will return this size object. And this enumeration, it just contains all the versions. For the pixel ratio, let's say that it will be 1. For the default device name, again, we have mobile devices. Here, I will assign it to Galaxy's S20 Ultra. Again, this is just a class with all of the constants, which are all of the devices names, which will be used for responsive testing. For the user agents, we have mobile user agents. Again, I will set it to Samsung Galaxy Ultra, and for mobile emulation, by default, I will turn it off. For now, this will be our web settings. However, I'm going to create one more class right here in the static implementation. I'm going to name this particular class timeout settings. what these timeout settings will hold? If we look here in our wait strategy, you will notice that every time we are hard coding these magic numbers here, 62 seconds for the sleep interval. We have specific timeout for the strategy about to be clickable. We have totally different timeout here for validate methods. Right here, again, we're hard coding that, but this is not the best practice, right, to have all of those magic numbers. So on multiple places we just hard coded all those numbers, and we don't want that, and we want to have the flexibility to update those timeouts based on our instance, on our test environment. So in order to do that, first we will expose 3 timeouts that are part. These 2 timeouts are part of the WebDriver. We have the page wall timeout and the script timeout. And you'll say, wait a minute, what is this 30? What this means? These are 30 seconds. However, it won't be clear, I mean, if it's just an integer, what we need to assign here. One of the ways to solve that is to rename this property to seconds here. And this will mean that when you assign a number, it will be in seconds. When we pass it to timeout, this will be version 1. Second version will be to use here this type of a summary. And this means that, for example, if I may make this property static, and if we use here this static property, let's make a constructor so that I can show you. Timeout settings, and as you can see, if I hover now this page wall time, it says, if you see, get or sets the page wall time in seconds. So this type of summaries, they're really great because they can suggest what type of integer is that. So I would suggest, if you use integers, do that. I mean, place this type of summaries and explain that these are not milliseconds, but these are seconds. Also, I'm not going to make that static. In a second, I'm going to explain why. Another option, instead of every time using this type of casts here, because everywhere we need time span, right? This is a special class in C#. Why we don't just make our timeout settings, all of the properties, to be time span? This means that here, as default value, I can say time span from seconds, make it 30. Again, just for simplicity for now, I will leave the rest integers, but you got what I mean. Maybe it's worth making them time span. So I will add 2 more, wait for 𝐝𝐥𝐞 timeout and sleep interval. This wait for 𝐝𝐥𝐞, if you remember, it's part of our browser driver adapter right here, where we are using WebDriver wait, and here again we have these magic numbers, and we don't want that. We need to refactor this later when we have our settings classes. And for all of our wait strategies, we'll have separate settings for that. For example, element to be visible timeout, element to exist, not to exist. As you can see, not exist and not be visible, they are short timeouts, they are just 10 seconds. This will be our timeout class. And I will have one more. This one more will be called grid settings. I'm going to create it right now. So these grid settings, it will be very similar to, and later I'm going to delete this grid configuration that we had before. It will be similar to this one. Again, on purpose, I'm not making it static. In a minute, I'm going to explain why. Again, here the provider name by default will be lambda test. If you remember, the options name is this AOT options. This is the thing that we basically supply here with this new, if we switch to C#, when we use Selenium 4, and if we use the capability for 𝑨𝒏𝒕𝒐 protocol, we need to add this as additional options name, and then all the capabilities. This is why we need that. For the URL, we are going to replace that later, but this will be the Lambda test URL here. You can change that if you use something else. And for the options, I'm going to copy the default values from our Lambda test attribute. As you can see here, we are already initializing, as I said, we are partially implementing the options design pattern, but we are doing that inside our attribute. However, I'm going to fully implement our pattern, and this will simplify our attributes later. So right here, I'm going to basically initialize it to a new dictionary of string object, and we'll have all those default values right here. Now, since it will be one of the things to consider, if we have multiple of those settings classes and all of them are static, it will be really confusing, and you have to know that we have so many of them, right? Because they can be 10 settings classes, but you need to know if they are static, you need to know the exact name and that this particular class exists. Instead, as I explained, many often we implement fluent interface, meaning that we use web settings dot timeout settings dot something. However, if everything here is static, we won't be able to do that. Instead, this is why all the statics properties will be only in our web settings class. And in order to access the timeout settings and the grid settings, I'm going to, since all of their properties are not static, we're going to access them like this. We have a static property inside our web settings that it's returning just timeout settings and grid settings. This will be initialized with all of the default values, which is excellent, and the same for the grid settings. And now, if we need to use the web settings, it will be quite easy. If I go to my here, I can say web settings, timeout settings, and then element to be clickable timeout. Again, this right now is integer, but I can return time span here, and I can say time span from seconds 30. You see the benefit now. Again, instead of every time calling time span from seconds, we are hiding that in the options class, which is awesome, and we can use the settings like that. If we need grid settings now, in a minute, let's refactor, for example, the our browser life cycle plugin. This is another benefit. If you remember, if we look into our web tests before that are here, right here in the product purchase tests, right now, until now, we could place this attribute and override the browser with the lifecycle, whether this is restarting it every time or reuse it, to use mobile emulation, etc., all of that. And this will be reused for all of the tests. However, if you want a specific test to execute on different browser, let's say here we want Edge, that's fine, and we want something else, reuse if started, we can do that. And also I can place here the Lambda test attribute as well. However, imagine that we have, I don't know, maybe 100 of these test classes. I don't want everywhere to switch that, especially the same is valid for mobile devices. I don't want that. And by default, I want to make our browser lifecycle plugin. If I don't place specifically these attributes, I want this configuration to be loaded from my default settings, from the web settings class. And in order to achieve that, we need to refactor our browser lifecycle plugin. If you remember, we're using here some reflection to get the Lambda test attribute or the local execution. And from there, we are initializing these two configurations, the browser configuration and the grid configuration. So in order to support what will happen if we don't place the two attributes on top of the class or on top of the test, this means that these two classes here, both of these values will be null. This means that this configuration will be null. And this means that in this case, we can say like that. If the browser configuration is null, then we can initialize it. We can initialize that from the web settings. Again, from in order to simplify the refactoring, I left our browser configuration file. Later, maybe you can not use it, but again, I prefer not to refactor my core logic for reading directly the web settings. I prefer to leave it like using the app configuration and the browser configuration. And right now, if we don't place the two attributes, and if this is null, then we are creating a new browser configuration and we are initializing it from the default values inside our web settings, which is excellent. And we can do something very similar. If here we don't have lambda test attribute, and if this is null, then all right, we are initializing the grid configuration like that. We are reading the grid settings, the provider name, and all of that. Excellent. And we'll have the provider name, the URL, the options name, all of the arguments and everything. And we can continue doing this type of refactoring everywhere. Now, until now, we just have default values, but for our local execution. How to implement? If we return, if you remember, here we haven't yet implemented this configuration loader. Let's see how we can do that. This configuration loader again is responsible for having different web settings for the various configurations. How we are going to switch the configurations before implementing the configuration configuration class? Well, in our test project here, this demo tests, I'm going to create a new JSON file. This is a very popular approach in .NET. I'm going to use this launch_static.json. This is very popular for especially when we create websites using .NET, but I'm going to modify that and use it in our framework. So I'm going to create this launch settings. And these launch settings will define a few profiles. These profiles will give us this command name, project, not project, but development, then staging, and then here actually these are the names that we are going to use for the switch. And then later when you run your test through the command line, you need to call .NET test launch profile development. And then by default, .NET will initialize this particular environmental variable to development, staging, and production. And now inside our configuration loader, we can read this particular environmental variable and based on it load different settings. Let's see how this works. Again, we need to create a new class inside our settings folder here that I'm going to name configuration loader. Here is the configuration loader. I'm going to make it public. And again, here in a minute I'm going to present to you the implementation of those classes. But what we do here? Well, I'm reading the environmental variable that I told you. If it's not set, we'll just get development. And based on this environmental variable and its value, we have a switch. Very easy. Based on the switch, we have three methods. These three methods will be responsible for initializing the default values for all of the environments. Like that. Of course, we change that to be a time span. This means that here I need to change that to 60 seconds. And of course, you need to refactor those everywhere. Here it will be 45. Visual Studio is suggesting how to fix that. Alright, so everywhere, if you refactor those to be time span, then you have to fix that everywhere. But again, based on the environmental variable, we're executing, for example, staging. Let's say that I want to execute all the tests on the staging. This means that this method will be executed. As you can see, we are calling the static web settings class with all the basically I'm saying that this time I want to execute everything inside lambda test, which is fine. While our QA environment is executing locally. So on lambda test, I'm saying please restart it every time, while locally we can reuse the browser. Here I switch the browser to Firefox, and here I use Chrome. We can change the version. I change basically here the pixel ratio, but actually we don't need even to set all of those since the mobile emulation is false. I have different timeouts for different environments, which is excellent. And depending whether I have a local execution or not, as you can see here, the grid settings are no, but here we initialize them for lambda test. And I did the same for the development environment as well. And this is excellent. If you have more, then you have to define a new method here and a new switch. This is the only thing that you have to change. After that, the switch is just through these launch profiles. That's it. I did absolutely the same refactoring, but we won't spend the time now to refactor everything for the Android. But I want to show you these settings for the static implementation for the mobile as well. So here I'm just going to copy the implementation of those files. Like we have the Android settings, but again I put all of the execution type, the default lifecycle, the default browser, we have the default device name, the default app package, etc., and all of the grid settings. Again, these two, actually all of its properties, they're not static, but basically they're almost identical to what we have in the web, but I suggest to use totally different settings classes so that you don't mess them up. And we have a similar configuration loader. Again, we have a static load configuration file, and again we are for example locally we are executing everything on our local APM server, local path to our application. Otherwise we are using lambda test. That's it. And one thing that you need to consider when we use the configuration loader, you need to basically add a test setup class here. If you're using, of course, NUnit, we need to add this test setup. As you know, in NUnit and in MS Test we have something called assembly initialize, which is a special method that will be executed only once for the project, for all of the tests, right? Like here. So we have this one-time setup, and we can execute any logic. And this is the place where we need to add our configuration loader, for example, for web. And then here I need to say load configuration, and we need to do the same for the mobile if they're in the same project. That's it. But again, you don't need to be sure to add that, otherwise nothing will work, right? Or you can call this every time in the classes in it, but I don't suggest that. Just use one-time setup, right? All right, let's review our second approach using JSON files implementation. For that, I'm going to mix both approaches. I'm going to show you two ways how to do that. First, let's add our JSON file. I already created one. Let's call this test framework settings. I'm going to add this file here, this test framework settings. As you can see, it has a very similar JSON structure, similar to our options classes, right? It has a root, the web setting, we have the execution type, but of course this type, everything here is string or a number. So we have restart every time, Chrome, browser version, we have the timeout settings, the grid settings, the end read settings, etc. Now, we can combine that, and I'm going to implement that using the launch settings. However, alternative approach will be to use this configuration manager here, the configurations, build configurations. For example, in 𝑣𝒏𝒕𝒐𝒏, the way we work with these configurations is that the only configuration that will be copied to the bin folder will be the one that holds the correct suffix equal to the configuration picked right here. And in order this to work, this will ease your job, especially when you're in Visual Studio, instead of assigning these environmental variables every time. But again, it will be up to you. This approach has its downsides as well, because through time I noticed that Visual Studio has some bugs, and especially for watch solutions with many projects, not when you create a new configuration here, sometimes it's not created for all of the projects, which is a problem, and you need to fix the solution files and the MS build projects by hand, which is not good. So let's use this approach. I'm going to create a special configuration folder inside our core project here, and I'm going to call that configuration. I'm going to install a few dependencies that are coming from Microsoft in our project. Here are our dependencies. These are the projects: Microsoft extension configuration, environmental variables, JSON, this is the major one, the configuration, Microsoft configuration, and configuration binder, which is responsible for serialization and deserialization of these JSON files. This will be one of the things. The second thing that I need is that inside here I need to create additional versions of my options classes. However, they will be slightly different, and I'm going to copy the same but for the web right here. What is the difference? Let me show you. The difference is that now they're not static. Also, most of them, like here, they're actually string. They're not actually enumerations. Later we need to do that manually when you cast that. The same for the time. Instead of time spans here, we need integers. And yeah, and here we will place two. We will have basically two special classes. Let me show them to you. This is the configuration service. This configuration service is responsible for reading the configuration file, and after that deserializing a particular, serializing a particular JSON section and converting it back to these option classes. For example, here I can say configuration service dot get section. Since it's a generic class, I can provide here web settings, and then after that I will be able to call, for example, timeouts, something, right? Or I can do the same for Android settings or any type of options class that we have. How this works? Again, we are using Microsoft extension configuration. This is why I exposed that through, we need that iConfiguration root. The root of the configuration is actually this particular node, reading the whole configuration. And as you can see, we have just two methods. One of them, the most important one, is to initialize the root. The way we do that, I made and I converted here this to be copied always. And this means that all of the configurations, this means that for all of the environments, so we will have QA, we will have development, so this suffix will be the suffix of the file, will correspond to the launch settings here, to development, staging, and production. So I'm going to add one more. And as you can guess, all of the values here, for example, for the staging might be different, right? I can change them. The whole point is how I'm going to load it. And I'm going to change it. For example, here I can delete the grid settings if you are not going to execute them, right? And leave it like that. I can change them a lot, right? For every particular environment, we'll have a different configuration file. That's it. So into the configuration service, I'm getting all of the files inside my assembly in the bin folder, all of the files in the execution there, and then using Lambda expressions, we are getting the first test framework settings that ends with JSON, and I'm sorry about that, this is the right version. We are reading the environmental variable, which is like again .NET environment. By default it's development. We are formatting the settings file, and we are using the builder that will just get again the execution there, the settings file path, which we are going to combine the bin folder with the correct settings file, and we are going to add this JSON file to the builder. Later, when you say get section with this section name, the thing that I'm doing here is that when we get the name of the type like web settings, we're making its first name to lower, which means that like here, or maybe you can skip that if you use like this syntax with capital letter, but I usually prefer to use the approach with like the way we name private variables, the same way I name sections and variables here. This is why we have an extension method that it's making the first letter of the string to lower. This is how our configuration works. And again, this get section, get method, this comes from the Microsoft library, will read just this part of the JSON configuration file and map it, initialize our web settings or grid settings or whatever section we provide. And again, this will work both for the web settings and for the Android settings. Let me show you, for example, here for the Lambda test plugin. This plugin, the way it works is that, not this one, but for the mobile, as you can see here, we can read that from the driver factory, or we can use some configurations. Imagine that we have the execution type, and we can get that from our configuration, like that. And I'm going to add the Android settings. We are going to use the files version. So how this works? We are getting the execution time from our Android settings. This is the execution type, and then I'm checking whether the execution type is a Lambda test or not. And we can use similarly in the browser execution plugin, right here in the browser lifecycle plugin, sorry. We can use the same logic, like right now, if we can get the particular section and we can initialize it if we change that right here. Let's say that we don't want this logic, but we want to use web sections. Actually, this is for the grid. we have a similar one for right here. As you can see, get configuration, we're getting the web settings, and then we're initializing all the web settings, providing to the constructor to the browser configuration. Or you can do it similarly like this. So everywhere where we need web settings now, we can provide them like that. Also, this particular approach, since this is not static, we can expose it through our app class here. For example, imagine that we can have a public property of web settings, but I'm going to get the files version. I'm going to call this web settings, and every time we're going to read that through the configuration, which is excellent, meaning that even if you implement your own app class, you can expose that instead of every time using the configuration service. You cannot do that with the web settings that are static. This means that you need to use them outside of the app class, which is some kind of a drawback. Another thing to consider is that if you want to extend the static version, like here, you can create a class called web settings extensions. You need to create a public static class where we'll have, for example, public I don't know, void at get some new settings. And in order to be able to access this from the web settings, we need to make this particular method static, and then we need to call web settings like that. And after that, when you use the web settings, for example here, and you can do that in your own project. For example, if you use it outside of this particular repo, I will have now this access to the method as an extension method. But we need, of course, to add a using statement. All right. And also another benefit of using the approach with JSON files is that actually you can define your own sections here. For example, imagine that you need to add API settings. API settings. You have, I don't know, a URL to your API. Your API.com. You have some other arguments, etc. For example, you can have, I don't know, default port 3002 and other stuff. This means that you can add such custom configurations. You just need to create additional options classes, and this will work out of the box. This is a very popular approach for example, when we want to create custom plugins and we want to switch them on and off, or adding, for example, if you implement I don't know, Azure Cognitive Services or something to Amazon services, then we need to provide some URLs, some data here. We can add such sections. You can achieve slightly similar thing with extension methods for the static classes, but again, it's slightly more difficult. Now, if we need to compare the static against the JSON files with sections, the static implementation have the following pros. The compile time checking reduces runtime errors. Like if you make a mistake here in the JSON, it will be harder to, you don't have the type safety. This is ideal for small projects with infrequent configuration changes. It's easy to access, easy to use because of the static properties are readily accessible through the application. You don't need these external dependencies to these Microsoft NuGet packages. Also, however, it's limiting the flexibility. You cannot add it to your base test classes or base pages or whatever, or app class. Extending configuration requires extension methods. Usability can be challenging as configurations cannot be easily integrated into the app and these base classes, and you will need to read the full documentation to understand the usage. Managing and maintaining settings become difficult as the project grows, especially with multiple environments, and requires manual creation of configuration loader classes if used as Git submodule. Configurations, of course, they will be basically different for each team and environment. While the JSON files, there are some drawbacks as well, but they allow for custom sections and easier extensibility. They are more user-friendly if integrated into app and base classes. They are better suited for complex setups and environments where configuration changes are frequent. However, without the integration into base classes, usage can be cumbersome as sections need to be loaded manually with this getSection generic method. Requires additional dependencies like Microsoft NuGets for configurations. It's less type-safe compared to the static properties with potential runtime issues, and needs robust error handling for missing or malformed configuration files. So, static implementation is great for small projects with stable configurations, offering simplicity and type safety, but lacking flexibility, while JSON files with sections provide greater flexibility, modularity, making them suitable for larger projects with dynamic configurations, despite added complexity and dependencies. This was our summary. Next, we are going to cover and develop many more complex web components, and we are going to add them to our 𝐴𝒏𝒕𝒐𝒏 project. It will be quite interesting. We will use a lot of JavaScript, we will see. Many often we need to do that for enterprise projects, so this is really vital to understand how to do it. Thank you for watching. If you have any questions, put them in the comment section below. Also, don't forget to check the Lambda test blog and the community website. And don't forget about the free certification about JUnity, NUnit, Selenium, Appium, and many other technologies. Thank you for watching, and see you in the next module.